we are going to state whether these equations given down are oxidation or reduction. Now we are going to base on this. Oxidation is an increase in oxidation number. And reduction is a decrease in oxidation number. So here we are going to do this. The conversion of hydrogen ions to hydrogen gas, hydrogen molecule actually. So here we shall have hydrogen ions gaining the 2 electrons to become the hydrogen gas. So this is a reduction because hydrogen ions has gained electrons. We are going to look at how it comes down here. So here we are going to look at the conversion of iron 2 to iron 3. If you convert from iron 2 to iron 3, that means there is an increase in oxidation number. So if the numbers increase, that means this is an oxidation reaction because iron 2 has lost electrons to become iron 3. So that is an oxidation. Now if copper 2 ions is converted to copper, that means this is a reduction because copper 2 ions has gained electrons to become copper solid. Finally here, for conversion of zinc to zinc 2 ions. If zinc is a solid, it loses the 2 electrons to become zinc 2 ions. Then we shall form an oxidation reaction because zinc 2 has lost the 2 electrons. Now, if this one, if there is a loss, this what happens, the zinc loses 2 electrons, they are negative 2 electrons to become zinc 2 ions. That one is okay. Now, if the zinc 2 ions gains the 2 electrons, zinc 2 ions gains the 2 electrons, it becomes zinc solid. This one is a reduction equation because it has gained electrons to become a solid. So you take note of this. This is a loss, this is a gain. This is a loss, this is a gain. So I will give you equations here and then you do some few and you give me the feedback. So let's look at these other ones here. Now there are simple rules of how to come up with these equations. Rules in writing, okay, let's start from here. Ionic equations. Ionic equations is used to describe a chemical reaction. It shows you the chemical reaction, whether it is oxidation or reduction. That is how it shows you how the chemical equation occurs. While also clearly it indicates which of the reactants or products exist primarily as ions. An aqueous state. Which of those ions really or get involved in a serious reaction in that equation? So if you cannot derive the ions present in an equation, then it is high time we change and we go back to the ions and we look at them. So here, so this is what I mean. The ionic equation is used to describe the chemical reaction. Then also it indicates okay, simple rules in writing this. Stop writing on our screen. Simple rule one is to start with a balanced equation, molecular equation. Start with a well-balanced molecular equation. If you cannot write a balanced equation, then ionic equation is going to be hard for you. Last time we looked at how to come up with a balanced equation. So make sure you know how to write a well-balanced equation. So this molecular equation, this equation shows the chemical formulas of all reactants and products, but does not expressly indicate the ionic nature. So for us, we are interested in the ionic nature since we are going to form the ionic equation. So make sure you know the ions present in that equation. An example is this. This is sodium phosphate. You know the phosphate, this 3 is for the phosphate. That's why the sodium being that 3. Fluorine, the 2 is for the chloride, the calcium. Then sodium chloride is at this, then calcium phosphate at the end of the day. So here we are forming aqueous solid, aqueous solid. Those states are very important in writing the ionic equation. Secondly, break all soluble electrolytes. Soluble electrolytes, these ones are the ones that are in aqueous state. Compound with AQ, aqueous. There is no way you can write. Now, the simple rule is when you are writing this, number one, what is a solid? What is a solid? It remains as a solid. What is a gas? It remains as a gas. What is a liquid? Remains as a liquid. That's why states are very important in writing equations. Whatever is put as a solid, an example, sodium is a solid. This one does not change state, also does not ionizing. What ionizing means it becomes iron. So sodium, that's something that is a solid, remains as a solid. Whatever is a gas remains as a gas. The state is G. Whatever is a liquid remains as a liquid. No, it does not ionize. What ionizes is something in aqueous state. Aqueous, that means it has been dissolved in water. So when something dissolves in water, it dissociates or separates in two component ions. Two component ions. An example is sodium chloride. An example is sodium chloride, aqueous. This one means there are two ions. Here we have sodium ions and then chloride ions. This is the nature. This is what dissociates, but not solids, liquids, they remain. Let's take an example in this equation of ours, what we have on the screen here. That is our equation we are going to dwell on. We have sodium, 2 sodium, 3 PO4 aqueous plus 3 calcium chloride aqueous will form what we know as sodium chloride here. Sodium chloride is solid, it's aqueous. It is 6 plus calcium 3 phosphate, and this one is a solid. Now check out where aqueous is. Where aqueous is, all those must give us ions. Whatever is a solid like this one, it is going to remain since they want the ionic equation. ionic equation. At this stage, we are going to derive ions. Whatever is aqueous is going to dissociate. Now, this 2 is behind here. So we shall write 2 ions present here. Here. We shall have, because it is in aqueous state, we shall have 2 open brackets. We have 3 sodiums, 3 sodium. The charge of sodium is +1. It is in group 1. Then we have a phosphate ion, PO4. The charge of a phosphate is 3 because when you are writing this equation, the 3 comes from here. So we shall write 3 minus, because it's a radical in aqueous state, plus 3 calcium, 3, because 3 is for all of this. This 2 is for all of these. That's why we put them in brackets. Then we shall have 3 calcium. Calcium has a valence 2. That's why the chloride took the 2. So it becomes 2 plus, because it is a solid. And then we have the chloride. There are 2 chlorides. A chloride has a -1. I gave you this list of these ions last time, so make sure you compare and see the ions. If you extract out a wrong ion, then you are not going to write the correct equation. So this one is in aqueous state. We form number 6 sodium ions, because 6 is out for both of them. Then also we have a fluoride ion in same bracket. This is aqueous. Now this one is a solid. This one, it does not separate into ions. It remains as calcium 3 PO4 in brackets 2. It remains as a solid. No, it does not separate into ions. Separate into ions. So it remains. We have derived our ions. We have got them, ions. So how do we know that? How do we remove this from here? Check out what is on the left-hand side of the arrow must balance with what is on the right-hand side of the arrow. So this one, the arrow is here. Whatever is this side must balance this side. And if it is in aqueous state, check whether they are the same. And then ions that are the same, out. Then the rest remains. So let's look at that. At this level, we have this. These are 2 times 3, 6 sodium ions in aqueous state. So this one, because of 2 times this, we get 6 sodium ions. Here we have 6 sodium ions. So sodium ions, 6 of them cross each other. Secondly, we have 2 phosphate ions. Check this side. Do we have phosphate ions? Nothing. So that one remains. We have 3 calcium ions. This side we have 3 calcium ions, but they are not here. They is in the fused state. So then we have 2 times 3 times 2 chloride ions. These are 6. Check here, if you have 6 times this, give you 6 chloride ions. So the chloride ions cross out. So right now you write what remains. Right? What has remained? It is ion state. So here we shall have, here we are left with only 2 times this, which we have as 2 phosphate ions. That's what has remained there, aqueous. Calcium is this one. Look at this. These are 3 calcium ions, 3 calcium 2 ions in aqueous state. We shall form. Here there is nothing, all of them have gone. So we shall have this one now. Calcium 3 PO4. then 2. So at the end of the day, you must make sure that they balance. So these are 2 phosphate ions. At the end of the day, they are there. So the equation is okay. 3 calcium ions, they are here. So our equation is okay. That is the ionic equation. At this stage, can I invite questions before I move any further? Inviting questions. I'm inviting questions. Questions?
Shami, I've not understood why doesn't the solid separate into ions?
Now, let me answer that one. Solids are stuck together. They cannot separate because it is. Can you separate a metal?
No.
Good. So if you cannot separate something, don't struggle. You only separate what ionizes or what dissociates or what separates into component ions. Have I answered you? Yes?
Yes.
Any other question? Any other question? Yeah. Questions? Shelly.
Sir, excuse me.
Yes.
Sir, at the beginning of the ionic equation, why didn't you cross out the potassium phosphate? Because it was matching with this last potassium. This phosphate at the beginning of the, because if you see, there are 2 phosphates and I think they should cross out this and this.
No, they should
Because
not.
if you
Actually, let me put that.
bracket is for
Okay, let me answer this. It is like this. Can we listen? Listen.
Chana charo kujibusa moto yo aware.
Okay.
Mama pere kanti d'accord.
Why we did not cross out this phosphate is there is no phosphate on this other side of the equation that we are supposed to cross it out with. So it will remain as a phosphate because the calcium phosphate is here. It has formed the 2 phosphate ion, which is a solid. It is no longer in any other aqueous state. So we cross out the ions that are this side upper and they are on the other side of the arrow. They must be the same. Like here, 2 times this, you get 6 sodium. At the side of the equation, we see an aqueous state that has 6 sodium ions. So these ones cross out. Then the 2 phosphate, 2 times this, you get 2 phosphates. Where is the phosphate on this other side? It is not there. The phosphate we have is in the solid state now. So we cannot take that. Then here we see 3 calcium. Where is the calcium aqueous state here? It is not there. It is in the solid state. So it fused with it, or it combined with the phosphate to form calcium phosphate, which is a solid, which is hard to separate. So at the end of the day, we shall have 3 calcium ions remaining here, and then we have 3 times 2 to make 6 chlorides at here, and then here we also see 6 chlorides. Then we shall cross the chlorine, and then whatever remains we write. You check here, you say 2, the sodium went, so what remained is a phosphate ion, which is this. We are writing what remained here. Then 3 times the calcium which remained, which is 3 calcium. At the end of the day, it helps us to form the calcium phosphate. Actually, the main idea of using ionic equation is to see what are the major components that led to the formation of those solids, liquids there. Any other question? Any other question? We don't have questions now. We look at the second example. Let's look at the second example. Let's look at the second example. Let's look at the second example here. Our second example is here. Let's look at this. Write the equation and balance it. We have one sodium chloride. This is our example here. Let's look at this. This is they want the ionic, write the ionic equation of this word equation. We have sodium chloride plus silver nitrate. You get silver chloride, the solid, and silver nitrate aqueous. This is aqueous. This is aqueous. This is a solid. This is aqueous. We have sodium chloride. We have sodium chloride as this. Sodium has a valence 1. We are forming a compound. Chloride has also -1. So when they react, they form sodium chloride plus this aqueous. We have silver nitrate. Silver is Ag. It has valence 1. Nitrate is NO3. It has -1, all of this. So when they react, they change powers because all of them are 1,1. They just remain like that. We shall form silver nitrate, sodium chloride, aqueous. End product here is also aqueous. We shall form silver chloride, which is a solid. So silver is this, and then a chloride. A chloride is also this. So when the two react, there is nothing they can exchange because the powers are the same. It will form as silver chloride, which is a solid, plus sodium nitrate. Sodium nitrate is here, sodium and then a nitrate. So this sodium is 1. All of them have 1,1. So there is nothing they are fighting for. It remains as that. So we write sodium nitrate. So at the end of the day, we have our equation as that. So let's check if it is balanced. Here we have one sodium, one chloride, one silver, one nitrate. That is all. Now let's check out. Do we have aqueous states? Aqueous states, because they are the ones that separate into component ions. So sodium is here. We shall write sodium ion. There is nothing like what you can maybe use brackets. Then the chloride ion is there. Chloride ion, aqueous. They are now separating two component ions. Silver is there, Ag, which is a plus. Then we have a nitrate ion, which is that one, also aqueous. On the side of equation, we have silver ion, this side, plus a chloride ion. This one is a solid. Sorry, this one is a solid. So a solids don't separate. So we shall just write silver chloride as that. Silver chloride as that, a solid, plus sodium nitrate. Sodium nitrate is going to be associated into ions as sodium ion and then nitrate ion. This one is aqueous. Now, let's identify ions on this side of the equation and then the other side of the arrow. Left and right side of this arrow. Let's identify which ions are the same and we cross out. So here we have sodium ions. Sodium, it is here. So cross sodium and sodium. The chloride ion, do you have any free chloride ion this side? It is a few states as solid, so we cannot cross. Silver is here. Do we have any silver free ion? Nothing, so it remains. But we have a nitrate and a nitrate. So this side, they have brought so the end product we have a chloride ion, aqueous. The states remain. Silver ion, which is aqueous, to form silver solid. That is our ionic equation. Have you understood how those things come about?
Yes.
Have understood?
Yes.
I'll give you an exercise to do, but this time you make sure you send. Otherwise, it is not good to waste the time that we are doing some things here, yet you cannot work out them. It disturbs us a lot, and even you. Okay. So in the work I'm going to send, has equations like this. They are here. So if you can take a screenshot, better. But this is going to be our exercise. If you can take a screenshot, you can do it. This is our exercise.
This exercise.
Just lower the screen and take a screenshot. This one is going to guide you on information of these things. So when we
How do you take a screenshot?
just go on your screen. You just scroll your screen from the top. Go there.
Come on,
Someone will guide you. Someone will guide you on how to take a screenshot. Otherwise, I will also take mine and send you. Then you make sure you send.
I don't know.
You don't know. Look up your
So we are done.
You are done. Very good. So you help me. You help me send the work to those people who are saying they cannot take screenshots. Then
Okay. I'll send for you.
you do the work and then you send it on my WhatsApp line. I will check and mark. Okay. You do the work. After doing it, you send it on my WhatsApp line. I will look at it and give you the feedback. Before we close, let me invite anyone who has not been clarified with this work, because if you know how to write these equations, then our topic, the other one of carbon and its compounds, shall go back and finish it. So, any question? Writing questions?
Number.
What mine? Here.
Your WhatsApp number.
Writing it on the screen. That is what is there. It is here. Let me hope we have it now. Yes?
First way.